So you need to go back to the first basically screen of the software when you have this one, and open your basically project that you have saved it somewhere, right? So let's open the project, and that's my test well model, which basically I have uploaded for you in the Moodle basically a while ago. So open the project now and go to the analysis section. So just click on the well here. So this is my, let's say, typical nodal analysis for this Wellbore. So again, all the values, all the plots here are completely different from the coursework well model, because that's about another well, another test well model. So be careful, you're not basically doing the stuff on this well, but you're doing the same procedure on your coursework well model. So in part A, basically in part B, B1, let's say, I asked you to find out the maximum WOR here. What is the maximum WOR here if you have the steel economic rate of 1500 STB per day for the oil? So basically you need to run the sensitivity analysis on this parameter, change this parameter to increase the water production from the system until the time that you get basically the operating point or the oil flow rate less than 1500. So in this case, for example, my operating point conditions give me the 13,000, let's say, STB per day as the production rate. But in your, for example, coursework, you may have, for example, 4,000 something here. So you need to somehow construct some TPR here with different WOR here to give me finally what is the maximum water oil ratio to still have the basically production rate above the 1500 STB per day. So the 1500 STB per day is your, let's say, limit here as the economic, let's say, oil production for the well. So what I do for the sensitivity analysis here, because I have a kind of very high production rate in this example, I assume that I want to do the sensitivity analysis to find out how much is for the economic rate of the 8000 STB per day. So this is the example for here, but in your coursework that's 1500. So this is for today. And with the well test model, but for your coursework you have 1500 STB per day, and that's about the coursework well model here. So what I do for the sensitivity analysis, I just basically build several TPR here by clicking on that let's say plus, let's say, sign here. So I have already one TPC at the moment with 0 WOR here. So if I increase my water production, I would basically get reduction in my oil rate as a kind of, let's say, new operating point after the intersection from the new TPR and the IPR. So let's create one, let's say, let's say another TPC here. You still have the same wellhead pressure and the GOR. Don't change them, just change the WOR for the part, let's say B1 here.
What do we change the WOR to? What do we change the WOR to?
We will change it.
We will change it?
Yes.
Yeah, to what? What number?
I'll tell you now.
Oh.
So in this TPC, you can see that my wellhead pressure is 450, 800 for the GOR, and the first one is 0. So what I recommend you basically when you want to do the sensitivity analysis here, start, for example, with your WOR, which is I think 0.2 in your coursework for the first one. The second one, for example, something in the middle, let's say 0.5, and the third one, for example, 0.8, just to see what happens with your production rate within, for example, these ranges of the water oil ratio. So in this TPC, I would say that's my 450 for the wellhead. Again, these are the values for the well test model, not the first one. That's 800. So for the start, for the next one, I put 0.5. So that's my second, let's say, TPR here by 0.5 here. And the next one, again the same. So 450, the GOR is 800. And now I increase it, for example, to let's say 8 here. So that's now my third one. So look at the operating points here. This is the 13,000. This is now 89,000, sorry, 8,900, and this is 7,300. So my economic value limit was 8,000. So I know that my water oil ratio should be somewhere between 0.5 and 0.8. So this is basically the place that I need to discover more with putting more, let's say, water cuts here. So for the next step, I may, for example, say that, okay, you can still, for example, go to update this TPC with the new W, let's say, OR. Let's say, okay, if this is, for example, my 8,900 with 5.5, which is this one, I change it, for example, now to point, for example, 6. So I recommend to start with, for example, 0.1, adding, for example, to your water cuts, and then try to, let's see somehow where, for example, you may have that limit of the 1,500. So if I put 0.6 now here, and look at my curve now, you can see that now I have 18, basically 8,300. So I am still above the, let's say, limit, so I can still have more water from the system. So you can, let's say, from this 0.6, you can add now, for example, 61, 62, 63, until, for example, 70. So that's the procedure basically you would do with the water oil ratio, and the accuracy that I want basically you to basically put in the report is something with only 2 digits after point. So that's my accuracy. Don't go, for example, for the higher values, because that's not the thing that I am looking for basically, and I'm expecting you to do for me. So only, for example, 2-digit points after the point for the WOR accuracy would be enough for the course one. So that's why now I, for example, select 0.61 and see what happened to the production. So I'm still above the 8,000. And you basically just repeat this procedure until you get something below just 8,000. So now it's 82 still. So I may go, for example, for, let's say, 6.5. So look at this value now. At 0.65, I have 8,000 something, right? So let's increase it to 0.66 now. So you are still above 8,000. And now you're less than 8,000, right? So this is for the water cut, the 67. So basically for the 67 is 7,960, the oil rates, and that's the WOR. And for the 6.6 is, it was I think 8,000 something. So which one I want you basically to give me? This one. Because I'm still above the 8,000. I am not interested in this one because that's below 8,000. So in the coursework, when you try to find out this WOR, or let's say water oil ratio for me, try to find that one which still gives you some value above 1500 or exactly 1500. If you're just below 1500, that means you just need to pick up the previous value of the water cut. So you know how to do the run sensitivity by just creating different TPC. If you just want to create multiple, or if you just want to modify, for example, the current TPC, that's fine. That's about the running sensitivity. Start with, let's say, 3 values for the water oil ratio, something very small, something very high, and something in the middle. And then find out in which, for example, window you might have, let's say, this one. When you find that window, try to, let's say, find out what is the WO ratio in terms of, let's say, 0.5, 0.6, 0.7, 0.8. And then you are happy with that, start to increase it to, let's say, another value. For example, if it's between 0.6 and 0.7, start, for example, with 0.61, 62, 63, until you get the value just below the 1500. So by using basically that sensitivity analysis, you give me the idea that how much would be my economical water production from the system. Because in reality, sometimes you may go, for example, to ask the manager that what is the economic, let's say, rate of the system, and they may tell you, for example, during the operational cost that we want to handle the water production, the only basically lowest value of the production rate, which is economic for us, is still 1500. If we are producing less than 1500, we are not getting any profit from the wellbore. So we need to do something for this wellbore, shut it down, or let's say do some treatments to increase the production above the 1500. So by putting that sensitivity analysis, you have the idea that in the future time, if the water cut reaches, for example, this value or this value, that's gonna happen for your, let's say, well production rate. So that's the, let's say, message, or let's say the purpose from the B1 here. For B2 and B3, I just asked to run a sensitivity analysis separately on WOR and also on the GOR. So you have the values for WOR.
The new one?
Sorry?
0.2 or the new one that we...
Which one?
WOR.
Yeah, WOR here.
We use the new one that we just do it, or the...
No, forget about part B after that. When you are finished with part B, you do for the part basically B2, and B2 just asks about you the running a sensitivity analysis separately on this model again. So in that, let's say B2, you need to put the value, different values for the WOR, and the values are 0.1, 0.2, 0.5, and 0.8. So you need to basically put these 4 values separately, and at the end you should have 4 TPC or 4 TPR plus 1 IPR. So let's look at this example now. I have 1 IPR here. The next one with TPC should be with the value of 0.1, because I need to run a sensitivity with these values now. The next one is 0.2. The next one is 0.5. And we need to create one more TPC here, because we still need to put a value, another value for 0.8. So here, 450 for the wellhead pressure, for the GOR 800, and for this one is 0.8. So you should get something like this with one IPR curve here and 1, 2, 3, 4 TPR for each value of the WOR. So I ask you to run this sensitivity for me and include that plot in the report and plus answer the question that I basically asked for after this sensitivity analysis. So when you want to report the plot, there are two options here. I think the easiest one is just create the a snapshot of this one, right? And then somehow crop, let's say, the only figure for me. So don't put the other things here inside the report. I just need, for example, that, let's say, figure from, for the sake of the report. Or you can do, if you want to do, for example, a kind of, let's say, more practice, you can right-click here and copy the data plot. So if you copy the plot here and go to the Excel sheet, just paste the data. You have basically the old data for the TPR and for the IPRs. For example, the first one and the second one is about analysis number 5 with X and Y here. So the analysis 5 basically is about this one. As you can see, that's about the oil TPC with the water cut off point 8 here. So it doesn't matter which one basically you want to use, just make sure that you include your basically plot here for me. So that's about the part B2. Part B3 is the same procedure, but we just need to change the only GOR now. So keep the WOR as the one that you have basically in your base case, and just try to change the GOR with basically every try that you want to create a TPC here. But the last part is about tubing. The last part is about tubing, which I think you need to make sure that you are doing the tubing one correctly. So what we are doing in the part BC, let's go back to the completion of the Wellbore here in the editors. Yeah. So I think in your coursework you have some, let's say, one or two tubings with different diameters, or no, only one tubing. So you have basically two tubing in your coursework. One tube, three tubing. One tubing with 4.5 inch. So the first tubing is at 3,460 feet with the internal diameter, the outer diameter of 4.5. The next one is at this depth with the outside diameter of 3.5 and 7,000 with 2.875 inch for all. So you have three tubings here. What you do in B3 now, you assume only one tubing, right? So you assume only you have one tubing size here, and that tubing size is basically until the depth of the 7,000. So you don't have, let's say, 3 rows in the, let's say, kind of a tubing data. You only have one row at the moment, let's say for a tubing, let's say, case, and that will be until 7,000 with the inner and outer diameter, which basically you have it in a table. In the table you have 6 basically tubing size available. So you need to make 6 well models separately. So first 7,000 with 3 and 3.5. So let's see. So let's delete one and put 7,000. The first basically tubing size is 3.5 and 3. So you can see that now you only have one tubing with this tubing size here. So what you can do here now, going back to the 3 and 3.5. So what you do now, go back to the nodal analysis, and because that's about, again, the only nodal analysis for part 3, sorry, part 4, so you don't need these stuff anymore. So this is now my production from the system, and just make sure that the TPC is equal to the base one that you have it in the model. So this is your, let's say, first model with the first tubing size available from the table. And we just basically look at the operating point and record that operating point because you need these rates to basically have the next plot in the report. So you do this procedure for the whole tubing size in the table that you have here. There are 6 available tubing size here. In every model, basically you just change the tubing size, going to the nodal analysis to just check how much would be my oil rate. So at the end, you should have basically a table something like this, which is about the oil rate and ID tubing size here. So let's say, for example, for the, it doesn't matter, you can go for the internal or basically outer diameter, it doesn't matter, but these are the values that you have for the inner one. So 3, 3.5, 4, 4.5, 5, and 5.5. Make the model for each one, go to the nodal analysis and record the oil rates for each one, and then plot this one in the Excel sheet for me.
That will answer that question.
And that would answer for the question.
This is an Excel sheet. This question.
Excel sheet.
So you
You
don't
need
need
to do the
to
Excel sheet here.
What question would that answer?
B4.
you don't need the screenshot for
No. So look at again the coursework when you are doing the coursework, because I'm thinking that it's somehow clear that what I am asking for inside basically the coursework. For some of the question, you just need to explain something, or for example, give me a number. If I say include your plot, for example, for the sensitivity analysis and explain something, you basically have the screenshot, explain something. But when I say that, for example, plot the oil rate at operating point versus ID tubing size, something like this is not coming from the software. This is coming basically from your values from the software and plotting in the Excel sheet, and then basically report after that. So in the, let's say, typical graph here, you need to do the Excel sheet, oil rate versus tubing size here. So basically you are going to investigate how much would be the changes in the production rate if you change the completion type here. So as a summary, as I said again, this coursework is in line a simple practice in the industry, not the real one, but the simple one at least. So in the part A, you are modeling the wellbore, and basically you are somehow simulating what you have in the field inside the software. Let's say in this example, IHS software. In part B and C and D, you are discovering and studying your wellbore behavior to see what's happening for your production rate if something happens. In part B, you are investigating if, for example, you have the excess water production from the system, if you have excess gas production from the system, or if you want to change, for example, the completion type, for example, change the tubing diameter to see what happens for the well production rate. Any question? Okay, so next week we're gonna have the decline curve analysis, and the next subject after that, hopefully, if we have time. And I just review again part A and B again with you, because part C and D is not still.
Two parts. I've done the first one anyway.
Have a good day.